Hello everyone, welcome to MLAS 800, and we're going to be doing Learning Activity 3C, a quick reference guide to LLM quantization. And for the final lecture, you've up to this point, you've a lot of lecture heavy this week with a short lab on just Google Colab. And we'll just do a quick short lecture here and wrap this up for LLM quantization. Quantization is something that basically, I mentioned it before and I wanted to go into more detail on this, is that you're scrunching down a raw file in a way. It is essentially what it is, down to a compressed file. And typically when we talk about FP 32-bit floating point numbers, when we're talking about quantization in this context, that's we're talking about the raw LLM. And when we talk about a smaller, like int for 4-bit integer or 8-bit integer, it becomes much smaller to work with. And there's reasons why we would want to do this, but it's it comes with challenges. But why is it important is because we take the large language model in its raw form. It's hard to run at that big, that it's at scale. It's hard even to scrunch it down and then run it. It's hard to do when it's in its raw form. So we make it smaller and faster and more efficient when we go through this quantization process. And it also helps to democratize. That's one thing I was talking about. And I'm going to give you some tools actually in this lecture that we won't be covering them in the course. There's the Spider IDE. We won't be using that. We'll be using Google Colab. But there's some neat studio interfaces for large language models that have been out for a few years now. And a community that helps to broaden support for this and make it where you can get access to these AI tools. But we scrunch these things down to smaller size so we can get them on mobile devices and edge devices, which is the ultimate goal, is to having your own personal AI. And you will be able to actually do that. You can do that. People do that today on their personal PCs. Now, it takes a little bit of horsepower to make it work. You gotta have a beefy GPU to make that work, but it is doable. So there are some complications when we talk about quantization. When we quantize a model and reduce, we make it smaller. It can create. It can make its behavior a little bit more uncertain. And in other words, it makes it a little less, it can introduce error, is what I'm saying. So there is a measure of perplexity, is what they call this. When I quantize a model, if I can keep it less than 1%, if I can compactify a model from, let's say, 100 gigabytes down to 10 gigabytes, and I can minimize the perplexity of that quantization process to be error prone to less than 1%, then that's a win. In other words, I'm getting a huge factor in reduction, and at the same time I'm minimizing the error, so that the information loss in the process of shrinking the model. So that's typically how that operates. There's a cost benefit to that, and usually the benefit outweighs the cost in terms of the shrinking process. And if you can keep it, again, less than 1%, that's pretty good. And so there's a lot of, this is another active area of research, is in the process of quantizing a model, can I minimize the loss, and make that even more efficient in the quantizing process? Because if I can get it down to approximate 0 in the loss, minimizing performance and information loss, and performance is maintained, at near raw performance, in other words, the unquant model's performance, then man, we're doing really well, right? And so that's an area of active research as well. And think of it as like compiling code. It's kind of the same way. Again, we won't go through the math. This is just there. If you're interested in learning more, there's actually a really good article out there that Medium put out, Quantization in LLMs and why it matters. It's a good, fun read. It's definitely not something you have to know the details of, but if you're looking for external reference in your research, that's a good one to use. Essentially, the basics of quantization is that it's reducing a tensor's precision and narrowing the range of values it can represent. It's a compression algorithm. Just think of it as it's almost the exact same process. And in terms of like when I take a video and compress it down, or when I take an audio and compress it down to an MP3, same kind of concept. And when you do that, we're going to be using in Google Colab. When we spin up a virtual model, the compressed file that we end up using is a GGUF, and so it's a C library. And most of the time it's either a GGML or a GGUF, that's typically what you'll see on Hugging Face. So once a model's been quantized, it's uploaded to Hugging Face, and you can download it from there. You can quantize a model yourself. It takes a lot of compute power. So it's generally, the community usually looks to Hugging Face, and people will upload their different language models to Hugging Face, and that's been kind of the industry standard in this area. So that's it. That's all I've got. We're right at 7 minutes here, and so maybe just 30 more seconds just to kind of go over resources. So we won't be using LM Studio, but I do want to give you, and I mentioned Hugging Face. So in your own time, if you're interested, it doesn't always work. It depends on, like, it won't run on my laptop, but you can, it's a really great resource, is this LM Studio. And you can download different large language models. You can run it on your own personal PC. It's pretty cool. You get that from the Hugging Face community. The GGUF, GGML files for the quantized LLMs are available for download on Hugging Face. You can write a Python package, is what we're going to do, to interface and access and get a LLM spun up. And we're going to do that with the Dolly Databricks LLM that's been published. But you can also download LM Studio. If you've got a beefy graphics card, a GPU that can get you going, it will get you going if you've got a GPU that's got enough horsepower to it to run the large language model. If you've got one that's, I want to say you need about 6, maybe 8 gigs on your GPU to do it. So if you've got a gaming rig, it'll work just fine. If you've got a laptop or a business computer, LM Studio may or may not work for you. So I run it on a 2070, NVIDIA 2070, and it seemed to be okay in an older one. So if you've got something that's a little bit more performant than that, it should work okay for you. And again, the memory size requirement, you're going to need something probably in the 6 gig ROM to make it work, maybe 8 on the GPU. So, okay, that's all I've got. I just wanted to give you some additional references, additional tools for you to go explore and use. We won't be using LM Studio in the class. We'll be, again, this is more of a programming course. We'll be focused on spinning up an LM up that way through code. That's all I've got for this week. This wraps up the last lecture for this week, and then next week we'll start heavy into the coding, and we'll get into the labs more predominantly as we move forward. Appreciate it, and we'll see you next week's learning activity.